Hello everybody, it's Mr. Woz. Welcome to WasleyScience. We are in our second semester now, and we are going to begin with air management. I imagine this video is going to be rather large. There's nowhere for me to really break it into two parts. So please don't try to do this whole video at once. Break it down into chunks. Alright, so let's get started. We're going to begin by talking about the layers of the atmospheres, just so we can establish what is going on there. So there are actually 5 layers of the atmosphere. The layer that we associate with the most is on the bottom, which is the troposphere. This is where all of the weather occurs. So you got your clouds, you got your plains. The highest mountains don't even surpass the troposphere. And what's significant about the troposphere is as you go higher in altitude, you decrease in temperature. Now this switches when you go to the next layer, which is the stratosphere. In the stratosphere, it actually gets hotter as you go higher in altitude, which is kind of strange to think. Now the reason why that the stratosphere gets hotter as you increase in altitude is because the ozone layer is absorbing the sun's UV radiation. So it's absorbing those harmful UV rays that could give us skin cancer. So without the ozone layer, we could be in some serious trouble. The next layer is the mesosphere. And the mesosphere gets colder as you get higher in latitude, so it switches. What's significant about the mesosphere is that that is where meteorites burn up. So if you've ever seen a meteor shower and you're looking up at the sky, you should say, "Thanks, mesosphere, for not having meteors kill me." The next layer is the thermosphere. And this layer gets significantly hotter as you get higher in altitude. However, what's strange about the thermosphere is that there are so few molecules at that layer that the molecules up there are moving really fast, but there's just not a lot of collisions going on because there's just not many atoms up there. As you go higher in altitude, there are less molecules, so there are less collisions. Our last layer is the exosphere, which is basically space. I mean, satellites are wrapping around the Earth in the thermosphere. The exosphere is basically space. Here is some notes on each of the layers, just a little snippet on each one. You can pause the video at this time and take these notes. I already talked about a lot of these things, so that's really the significant thing, so make sure that you do get this. Alright, so now we're going to get on to the composition of the atmosphere. Now most people think our atmosphere is mainly oxygen, and that's not true at all. Most of our atmosphere is nitrogen in the air. Nitrogen is a very important part of our atmosphere. Only a little under 21% of our atmosphere is oxygen, which is what we need to breathe, of course. And less than 1% is argon. And then we have some carbon dioxide. There's some water vapor there. And then we got all the little ones that aren't a huge amount, like neon, methane, helium, krypton, hydrogen, xenon, etc., etc. A video that I really recommend you watch is up here. It's by BuzzFeed. I'm sure you're familiar with BuzzFeed, and it is called "What If the World Lost Its Oxygen for 5 Seconds?" It's really interesting because it starts off like, that's not so bad, and then it just gets like completely apocalyptic. And then what I really like is at the end it talks about what if the world had twice as much oxygen for 5 seconds, which is pretty cool too. Alright, now that we have our atmosphere established here, let's get to the good stuff. Let's get to air pollution. Now, an air pollutant is when you have an airborne particle or gas that occurs in a concentration that is harmful to the environment. This is different than a greenhouse gas, and I can't emphasize that enough. Greenhouse gases are carbon dioxide, water vapor, methane, chlorofluorocarbons. Those are different than air pollutants. Those are greenhouse gases, and what they do is they can just make the earth or the atmosphere of the Earth hotter. That can be problematic if there's too much of that. That can make the Earth hotter than normal. The Earth does have ways of balancing itself out, and we talked about all that in last unit. Now, this is different. Air pollutants are a different story. Air pollutants are things that can affect your respiratory system. They can give you asthma. They can really make you sick. They can, in even some cases, they're carcinogens. So totally different thing. Primary pollutants are put directly into the air. So the pollutants that come out of a car exhaust, that's a primary pollutant. Now secondary pollutants, they're a little different. They're when you have some pollutant and maybe another pollutant or, I don't know, something else, and they form a chemical reaction in the atmosphere and then create a very harmful pollutant. So they didn't come directly out of a factory pipe or the muffler of a car or something. They formed in the atmosphere from different other pollutants. The last part here is the EPA, which is the Environmental Protection Agency. Probably my favorite part of the government, my favorite branch. Because the way I see it, the environment doesn't really have a way to defend itself. It's not like some sort of animal that could defend itself. It's the environment. The humans can pretty much trash it in any way that they want, but they can't because the EPA exists in the United States. And what these guys do is they monitor the amount of pollutants that are in the air. They look out for that, and they see when it is more harmful than it should be, when it's at higher than acceptable levels, and they decided over lots of data what is an acceptable level. And when it is higher than acceptable level, it gets on the news. You know about it. They may go into certain industries that are producing more than they should of air pollution. These guys, we're going to learn a lot about them over the quarter because they play a significant role in protecting the air, in protecting the water, and protecting the land. All right, so let's play a little game. Let's see if you can identify the primary and secondary pollutants. Your hint is that half of these pictures represent a primary pollutant and the other half represent a secondary pollutant. What you should do is you should write a brief description in each of the 6 pictures. Maybe label this pictures from 1 through 6. 1, 2, 3 on the top, 4, 5, 6 on the bottom. All right, so taking a look at picture 1, this picture represents ground level ozone, which is a secondary pollutant. So this is when you have some nitrous oxide and some VOCs that mix in the air, cause a chemical reaction. In picture 2, this is a mine being blown up so we can get to the coal that they're digging for, whatever metal it is. And what is happening is all the particulate matter and sulfur dioxide is directly going into the atmosphere. So this is a primary pollutant. In the third picture, you should have got this one right. That is a primary pollutant. So that is carbon monoxide, nitrous oxide going into the atmosphere. Our fourth picture down here is also a primary pollutant. This is coming directly from the smokestack of a factory. Our fifth picture here is the effect of some major acid rain. Acid rain is a secondary pollutant because when SOx and NOx mix in the air, they form acid rain. And then our sixth picture is an example of smog, which is very closely related with ground level ozone. So that is a secondary pollutant. All right, now we are going to get into the 6 big pollutants. Now I realize that we already made posters at this point and that you guys are pretty familiar with the 6 big pollutants, but I'm going to give you a brief description of each of them, which include carbon monoxide, nitrous oxide, sulfur oxide, or as we call them, the NOx and the SOx, ozone and VOCs, particulate matter, and then lead. And I'm telling you to make this pie chart right now because what this shows is which of the pollutants do we see in the highest abundance in the atmosphere. And we can see that carbon monoxide is the winner. There's 38% of the pollutants in the air is from carbon monoxide, and then closely followed by particulate matter. And then after that, it's basically the VOCs and the NOx and then the SOx. And you can see there that there's not really any lead. Lead is no longer a huge problem in the US, but it is really important to talk about lead because it was a big problem. And this pie chart is also very important. I had to make this one myself. So please make this pie chart as well because it shows where these pollutants mainly come from. And you can see that almost half of the air pollution that we have in the United States of America comes solely from our transportation. So our cars and our trucks driving down the highway, those long distances, that is what is creating, that's what our big problem is for pollution. And after that is the stationary source fuel combustion. And you're probably wondering, what the heck is that? That is power plants. So coal-fired power plants, natural gas power plants, that is where we're getting some air pollution from. Mostly from coal-fired power plants, though, because natural gas doesn't really release much pollutants. And then 15% we can see is from industrial processes. And then solid waste disposal, so that's like landfills. And then miscellaneous, which can include a couple things, such as generators, construction work, and a bunch of other stuff. All right, so we're going to start with carbon monoxide. So this is known as the silent killer. It is a colorless, odorless, toxic gas that is reactive. This is the one that mainly comes out of automobiles. All right, so your cars, people died from carbon monoxide poisoning, which is why we have carbon monoxide alarms in our house. What it can do to you is it can reduce the oxygen flow to the body, give you chest pain, and a high dose can, like I said, lead to death. It's especially dangerous in closed areas. It's not really dangerous in open areas, but there is a lot of carbon monoxide in our atmosphere caused from our cars. This is why you got to be really careful with your generators. You can't leave them running in an enclosed area like the garage, because the garage will fill with carbon monoxide. It's also released from fires and lawnmowers and grills. So carbon monoxide isn't really that harmful to you in open area, but it can be very harmful to you in enclosed space. Nitrogen oxide, which is known as NOx, so the X stands for, it could be a 2, a 3, even a 4. And this is, like I said, a variety of chemicals, and it leads to nitric acid, which is a part of acid rain. And it forms so the NOx can form in very high temperatures. It comes from cars as well, and power plants, off-road equipment. So a lot of farming equipment, agriculture processes release a lot of NOx into the air. It actually occurs naturally from lightning. And the problem with NOx is that NOx is a stepping stone, or like a gateway pollutant, to a lot of very harmful secondary pollutants, such as ground level ozone, which we're going to talk about in a second. And also it leads to acid rain. So nitrous oxide is a problem because it does lead to secondary pollutants. And those secondary pollutants and even NOx have adverse effects to your respiratory system. Next, we have the SOx, sulfur oxide, so the SO, SO2, SO3, S2O2, and sulfur oxide come from mainly coal-fired power plants. They do come from mining, when you mine coal, of course, and some industries, large ships, some off-road equipment. They even occur naturally from volcanoes, but the main culprit of this is the coal-powered plants. And SOx can be a pretty dangerous pollutant. It can lead to the formation of acid rain, so it's another stepping stone to a secondary pollutant. And SOx in itself can really affect your respiratory system, give you bronchitis, it's said to give kids asthma. So if you live near a coal power plant, that could be a big problem for small children and the elderly. So SOx is definitely a pollutant that you want to take seriously, not mess with. The VOCs, the volatile organic compounds. What's interesting about these is that they exist in different things all around your house. And they're usually chemicals with low boiling points, which means that they can evaporate pretty easily. And you can't see them, but you often can smell them. And their short-term effect is that they can irritate your eyes and your throats, give you I said throats like you have multiple throats. It can irritate your eyes and your throat. It can give you really bad headaches and cause you to be dizzy. Long term is that it can lead to, that's right, cancer and damage your nervous system, which is your brain and your liver. And guess where these come from? They come from a lot of chemical solvents like paint, varnish, gasoline, nail polish, adhesives like glues, photocopiers, cigarettes, stoves, lots of some cleaning supplies around your house, lots of stuff you don't really suspect. I remember, what happens to people that are painters? They often get cancer. They can get, not often, but they can get cancer at early ages because of the VOCs that they constantly work with in the paint. So that's why that they make it a really big deal to wear a mask when you paint. Volatile organic compounds can really mess you up over time if you're constantly exposed to them. So it's important when you're using any of these that you have you're in a large room, or that it's vented, or that you're outside, or that you have a mask. All right, so now we're going to talk about good ozone versus bad ozone. Now, like I said before earlier, good ozone is in the stratosphere. The ozone layer protects us from harmful UV rays that the sun emits. Now, bad ozone is something that we do, not directly us though. When you have the sunlight and it mixes with nitrogen oxides, so the NOx, which come out of our cars, and then those NOx mix with volatile organic compounds, VOCs, which come from all those other things I just said, you can get ozone, ground level ozone, not at the stratosphere, but like right at the bottom of the troposphere, right where we live. And that can be very, very harmful to children and people with asthma. This has happened several times in history. It happens in urban areas, especially in the summer, because you have extra sunlight then. So the pollutants basically bake together and form ozone. So like I said, you got the good ozone layer here. That's the ozone layer in the stratosphere, but ground level is in the troposphere, and it can really mess somebody up. It's often a problem right now in China, and we see it sometimes in Connecticut even. Particulate matter is a pollutant that is pretty common. It's a mixture of small particles and water droplets. So acids and chemicals and dust, soils and metals. It's kind of like the other of pollutants. We have PM 2.5 and PM 10, which means particulate matter 2.5 and particulate matter 10. Particulate matter 2.5 is smaller than 10. So 10 can get into your nostrils and your throat, and it can irritate you, and you might cough it up and be okay. You might even sneeze it out, blow it on a tissue, be fine. 2.5 though can really go deep into your lungs and start to cough and really irritate your lungs over time. and give people difficulty breathing that have asthma or irregular heartbeat. And particulate matter can even cause issues with visibility. A lot of it comes from just dust from construction, but cars, agriculture is a big one. Manufacturing will release particulate matter. So particulate matter is also not a thing you want to really mess with. In this diagram here, you can see that this scary looking thing here is actually human hair. So the pink is the 2.5 and the blue is the PM10. So you can really see the difference there. And that's what a grain of sand looks like. So just to give you an idea of how small this stuff is. Our last one is lead. And lead is an interesting one because it's not really a problem anymore. It's still out there though. Lead is a naturally occurring metal. We used to use it like in everything. We were crazy. We put it in gasoline. We had lead pipes. We put it in paint. We thought this stuff was awesome. And then we started to notice how toxic it is to humans and animals and children and pregnant women. It affects your respiratory system and your nervous system. It can accumulate in your body, which means it stays there forever. And then the additional lead that you put in your body stays in there on top of the lead that you had in your body. So it accumulates over time, the amount of lead that you get exposed to. And also, it really gives you brain damage. It can this stuff is by far the most toxic out of all of them. However, we barely have any of it in the air at this point because we took lead out of gasoline. If you go to the gas station, you see that the gasoline, the normal gasoline that you get, is called unleaded. The reason it's called unleaded is there used to be lead in gasoline. Now, they didn't really call it leaded gasoline. They just called it gasoline. But the reason the gas pumps call it unleaded is to let you know that, no, there is no lead in that gasoline. Cars and industries still release a small amount of lead. Not that much. It's mostly from some industries still use lead in things. But your main concern with lead is old houses. So like you may have a house that you're given a new paint job to and you're moving the old paint, and guess what? That paint has lead in it. So it's lead chips that you could inhale and become really sick. Or you could have a really, really old car that you haven't used for a long time and maybe there's leaded gas in it still, or some lead pipes in houses, but that's not exactly going to the air. That's entering you from water, so you're drinking that lead in that case. But yeah, lead is really no longer a problem, but it is something that we need to know so we don't make this mistake again. I apologize for this being blurry, but this is actually a really interesting set of pie charts here. What it shows is where each of the pollutants come from. And what I think is really interesting is if you focus in on all the light blue, you can see that cars release a majority of the carbon monoxide and nitrogen oxide in the country, but they also release VOCs. And then if you focus in on the yellow, which is like power plants, it says fuel combustion electric utility, but that's power plants essentially. You can see that most of that comes, that sulfur dioxide is the main culprit for that, but mainly sulfur dioxide and not much at all for carbon monoxide. And then when it says non-road engines in vehicles, those are just machines that don't have wheels on them. So a lot of agriculture machines, but generators and other things. So that's the red that I'm talking about here, and that's mostly carbon monoxide and nitrogen oxide. But yeah, I think that's all I really want you to focus in on is that light blue and that light yellow and just kind of see where they come from mainly. Now we're going to get to smog, but before we get to smog, we need to talk about a certain concept, a phenomenon that can happen with pollution, and that is called thermal inversion. And a thermal inversion is when you have the formation of a static layer of cold air that's close to the ground. So if you look at this diagram in the bottom right here, you can see that normally what happens is the air that's closest to the ground gets really warm because over the day the ground absorbs heat from the sun, and then it gets cool and then cooler. But what happens in a thermal inversion is what's all the way to the right, where the urban area is surrounded by cool air, and above the buildings and such is like this barrier, this like shield of warm air, and then cooler air on the top. And this is a huge problem because you're not getting any mixture of air. So you're basically just, when you have that diagram all the way to the right, you are just in the same air that you have been in for several days. And so the air that you breathe has not been mixed into the rest of the atmosphere. You're just kind of recycling air. And if everyone is creating a lot of pollution, it can be very, very dangerous. It can lead to something known as smog. And smog is this really scary fog that has soot in it. And it's formed when there are several homes at the same time using their fireplace. They could be burning coal, and all their chimneys are releasing smoke and sulfur dioxide into the air. And in addition, a thermal inversion occurred. The water from the fog can mix with the soot and the tar particles and form intense acid rain. It's a very scary thing. It usually will happen in the winter time because that's when people would be using their fireplaces. This has happened twice in a really bad scenario. One is in the Denora smog situation in Pennsylvania. And if you click on this video here, you can watch about it. 21 people died. It's a pretty crazy story. The Weather Channel loves talking about it. And then on the right here, we have London's Killer Fog, part 1 and 2. And this happened before the Denora smog. And it talks about this killer smog that occurred in London. And we are also going to be reading more on it. So at the end of the 3 units that we're doing this quarter, which is air management, water management, and land management, you're probably going to feel pretty depressed because it's going to sound at first like humans are doing all these awful things and no one's really seems to care or do anything. But I do have sections at the end of each of my videos, and they are called What is Being Done. And in the What is Being Done section, there will be 3 components of it. The first will be regulation. So these are like things that legislation and the government has put to slow down the amount of pollution. The second section is going to be on technology. So like what types of technology has developed over time that has limited the amount of pollution that goes into the air, water, land. And the third part is just awareness. And the awareness section will talk about different things that individuals are doing that really help out. So first, let's talk about what is being done in terms of regulations of air pollution. Well, the EPA was formed in 1970. Nixon was president at the time, and they provided a Clean Air Act. And the Clean Air Act really changed everything because the Clean Air Act provided a framework for restricting 188 different toxins that were in the air. But before 1970, air pollution was awful. It was just in the air. People were getting major respiratory issues. It was really tough. But the EPA put this through. It was really difficult to start, but they got it going, and it significantly started to drop the amount of air pollution. In 1990, they had a Clean Air Act, which was amended, and they created the Maximum Achievable Controls Standard Technology Standards, the MACT. And the EPA provided specific restrictions to industries and their amount of toxins that they could release while still keeping them competitive with rivals. In other words, they said, this is how much toxins that you can release into the air. They're able to monitor it now with a lot of technology. And so they give this to all the industries so that way every single industry has to follow by this, so every single industry can still stay competitive with one another. Over 10 years, it was really proved to be successful. Toxins were cut down 1.5 million tons a year. I'll provide you a link about the history of the EPA on the bottom of the video if you're interested. And in case you don't believe me how much the EPA and the Clean Air Act had an impact on the United States, here's a table that really shows it. So you can see in 1980 there was 178 tons of carbon monoxide in the atmosphere in the United States, which 178 tons doesn't seem like a lot, but this is like a gas. This is particles, okay? That's a lot. And you can see from 2012, we are now at 51. So it's gone down quite a lot. As well as lead was never really high, but now lead is super low. You can see that they have all decreased. They have all gone down, which is great. And this has to do with a lot of things, but a lot of it was the Clean Air Act because it put regulations on how much pollutants that a factory or a car or a power plant could produce. Now for technology, we have three main things here that really made a big part. The catalytic converter is used in cars. It helps reduce the amount of nitrogen oxides by separating the NOx to make N2 and O2, which are common things in our atmosphere. They also help lower the amount of carbon monoxide in the atmosphere. So they're hooked up to the muffler, so the exhaust area. And then you have baghouse filters. These are used in industries. They remove 99.9% of particles. It's always 99.9, right? It's never 100. But they force the gases get forced through a fiber bag before being released into the environment. They're like a giant vacuum cleaner, and they're like the size of a building. The only problem with bagasse filters is they don't really do anything with sulfur dioxide. They take care of the carbon monoxide, the NOx. They take care of the particulate matter, particularly. But for sulfur dioxide, we rely on wet scrubbers. These are also used in industries, and they remove sulfur dioxide. So they're used mainly for that pollutant. And what they do is they force the gases through a chemical spray and basically a bunch of water, and it absorbs the SO2. It's very expensive to build. It's also expensive to maintain, but it gets the job done. And when you have regulations, you got to do it. So if we can take a look at these pictures here, we can see the catalytic converter on the top left. It's hooked up between the engine and the muffler. Here's a closer look at it. If we look all the way to the right and the bottom here, those are all baghouse filters. So like I said, they're these giant vacuums. See all these are all like individual kind of paper towel looking things. They're giant cloth rods, and before the air goes out of the smokestack, it goes through from the bottom and then up, and it has to go through all those giant filters that take in all the pollutants. Now what you have to remember is eventually those, I call them giant paper towel thingies, get filled up and they have to be emptied, which means they have to get thrown away, which means they have to go to, I don't know, maybe a landfill, because if you go and incinerate them, then they'll just go back into the air. So it's not like it makes the problem completely go away. It just prevents it from going into the atmosphere. And then we have wet scrubbers. Both these diagrams are wet scrubbers. So what they do is the contaminating gas goes in through the left, and it is constantly having water showered on it, and then the water leaves, and then up above you have where the clean air gets released. So this requires water, which is a very valuable resource, and it's a pretty expensive piece of technology, mainly because it constantly requires water to go through it. And last, we have awareness. So through education, you yourself can be better at and release less air pollutants. So environmental science starts to get included in curriculum at school, which is like, what you're doing, I don't know, right now maybe. And the reason why we're doing this is so we can lower air pollution. So listen up, guys. And there's many things that you can do to do that, just as turning off your device when you're not using them, because by you turning off your device, that makes the power plant require less power to run your device, and when the power plant uses less power, they release less air pollution. By recycling, reducing, and reusing, you are purchasing less things, so not only are you saving money, but you are telling the factories to not make as much stuff. And by you doing that, as a consumer, you release less pollution. If you buy Energy Star products, you will buy more energy efficient things. One of the biggest ones, I think actually the biggest one on this entire thing, is carpooling. We all drive in single cars. We all drive to our own job and back. If people use public transportation, it's incredible how much of an impact that makes. It's just so funny how and it's just so many crazy things, like when people transport and everything. I mean, you could go on the highway and you'll see logs coming, trees, wood being delivered one direction, and then the other opposite direction. It makes you think, why don't those two trucks just talk to each other and just, I don't know, switch so they don't have to go as far. That's me just rambling. Anyway, promoting telecommunications at work. So this is actually happening now. So businesses, instead of working 5 days a week at the office, maybe they'll work 3, and then 2 days they'll work from home, and they can have conferences from their houses. Keeping fireplaces and stoves cleaned and maintained, that helps reduce the amount of soot that goes into the air. And then researching your own carbon footprint and buying desired products that don't release as much pollutants. Alrighty, guys, we did it. We got through air pollution. I apologize for the extra long video. In return, I have 3 videos for you to enjoy. On the left side, we have how it explains how air pollution is a big problem in China as well as other parts in the world. In the middle, we have little short animations on air pollution and other types of pollution. And all the way to the right, we have a short 20-minute documentary. It's called The Right to Breathe, and it's all about air pollution going on in the world. So please feel free to watch any of these videos. They're very interesting. All right, thanks a lot, guys, and take care.